Alright, this begins lesson 8.3, and again I'll preface saying that this will probably be a part A and a part B lesson. So first, let's look at the green part here and know that this lesson is going to be an exploration of sorts, and we're going to look at how changes in the equation of a quadratic function affect the graph. Okay, so just changes in the function affecting the graph. Does it move up? Does it move down? How does it change? So now it says vertex form right here, and that's what we're going to look at. Now if you remember, y equals ax squared plus bx plus c is standard form. Vertex form is of the form y equals, and actually you know what, I want to hold off on that, but it will look like this in detail. I'll show you later. It has something squared in parentheses. Okay, we'll get to that later in the lesson. Now I'm going to have at my disposal a graphing calculator. If you have one, that's great. If you do not, then I want you to know that you have one available to you. If you go on our course and you go up to under resources, this graphing calculator right here gives you an free online graphing calculator. Alright, and we will use that one during the lesson. Alright, so graph y equals x squared, y equals 2x squared, y equals 5x squared, and y equals 12x squared on the same axes, and describe what happens to the graph of y equals x squared. Now key is, this is our parent function. That's what is considered the norm. How did the other issues affect, like the 2, the 5, and the 12, how did that affect this function? In other words, what happens when the coefficient of x squared is greater than 1? So I'm going to go to the graphing calculator, and we're going to type these in. So first of all, we have y equals 2x squared. Actually, let's put the first one in there. Y equals x squared. Next one, y equals 2x squared. Y equals 5x squared. And then y equals 12x squared. And then graph. Now again, here's our parent function. When we have a 2 in front of it, what happens? It looks like it got narrower. When it's a 5, even narrower still. And then the 12 was narrower even more. Okay, so basically what we're saying is that as the coefficient of x squared gets, or is greater than 1 and gets bigger and bigger, then the graph will get wider and wider. Or excuse me, get narrower and narrower. And I want to say as the x coefficient, or as the, I want to abbreviate this, coefficient gets bigger. Okay, so what happens when, again, we take this parent function, and what happens when instead of 2, 5, or a 12, we're talking about 1/2, 1/4, and 1/10. Alright, so let's graph this on the graphing calculator. I've already entered them. Now notice we have x squared, which is already drawn in red. Notice that I put, instead of 1/2, I put 0.5 because I tried putting 1/2 in parentheses and it did not quite take it. So we'll just put them in decimal form since they terminate anyway. And if I graph 0.5, now we know that as the number in front of x squared got bigger, like 1, 5, 10, 12, it got narrower. If we have a decimal, meaning less than 1 but not negative, we have the green get wider. So if we try 0.25, we have yet an even wider one. So we can assume that then as that decimal gets smaller, then the graph gets wider. So again, but it's not negative, so keep that in mind. So let's say then that as the coefficient of x squared gets smaller but still positive, the graph gets wider. Okay, so again the key here is when it's between 0 and 1. Okay, if it gets bigger than 1 it's going to get narrower, but when the number in front of the x squared, the coefficient in front of x squared is between 0 and 1, it's going to be wider. And the closer to 0 you get, the wider it gets. What happens when the coefficient of x squared is negative? Alright, well, what do you think will happen? We've talked about this before. This is not new to us. So let's take a look at the parent function and put a negative in front of it. We've talked about what would happen. Let's see if you remember. There it is. It goes downward. So if that number in front of x squared is negative, the graph goes down. And that holds true in this lesson as it did before. So make a prediction and check it. Basically what we're saying is if the coefficient of x squared is negative, the graph opens downward, if you want to describe it as that way, or goes down, whichever works for you. Now let's take a look at a different perspective. We're looking at 5x squared, which is not different for us. We've already seen this. We said that 5 is bigger than 1, so that means it's going to make it narrower. What happens when we add something to that term or subtract something to that term? On this particular question, we want to make notice of the fact they're saying what happens to the graph of y equals x squared, or in this case y equals 5x squared, when there's a number added or subtracted after the x squared term. That's important because if you look down here, we have something different where you have something added or subtracted inside the parentheses. Two different questions. So first let's look at this. Now in this case, we're adding a 3 and we're subtracting a 7. So if we take a look at the graphing calculator, this is the graph of y equals 5x squared. And it is narrower, which we knew that would be the case from previous examples. Let's take a look at y equals 5x squared plus 3. Now if you look at this, if I look at the vertex, the minimum, it was at 0, 0, and now it's at 0, 3. So it shifted upward 3 units. So if that's the case, what do you think will happen with 5x squared minus 7? If plus 3 shifted it up 3 units, then minus 7 would shift it down 7 units. Okay, so when you are adding or subtracting a number from the x squared term, the graph translates up. Or when you add, it translates up. When you subtract, it translates down. Now the next one we have to look closely again. Instead of it saying adding or subtracting from the x squared term, now it's adding or subtracting inside the parentheses. So let me get that graphed. Alright, so I put the equations inside the graphing calculator. Again, here is 5x squared in red. Notice I had to put 5 in parentheses out front for this to work, for this kind of question. So let's see what happens when we add 3 to the inside. Now I would bet that you would think that adding 3 would shift it to the right. But in this case it did not. What about the 7? We would think that minus 7 would shift it to the left. But it shifts to the right. So when you are adding and subtracting inside the parentheses, then we have a different, actually the opposite result. So when you're subtracting inside the parentheses or adding inside the parentheses, this is what's going to happen. So when you add to the x term inside the parentheses, the graph translates to the left, opposite of what we would think. When you subtract from the x term inside the parentheses, the graph translates to the right. Counterintuitive, but it is important to know that this does actually happen. So again, when you're adding and subtracting from the x squared term, it does as it should. If it says plus 3, we go up, minus 7, we go down. If it says plus 3 in the parentheses, we go left. When it's minus 7 inside the parentheses, we go right. So inside the parentheses affects left-right translations. Outside, an affecting x squared term translates up and down. So let's take a look at this one right here and say, what do we expect to happen? Well, first of all, I will say that it opens downward. I want to get it so I can see that graph here. Alright, now it opens downward because it's a negative out front. I have a minus 1 inside the parentheses, so it's going to translate 1 unit to the right because it's opposite of what we think. And because of the plus 6 outside the parentheses, it's going to translate 6 units up. So again, inside the parentheses is opposite, and it is a translation left and right. Outside the parentheses is up and down, and it does exactly as it should, in this case up 6. How about the next one? Alright, because we have the 2, I'm going to say it opens up because it is a positive 2 and it is narrower. The plus 7 means it's going to translate, and you can say shift if you like, translate 7 units to the, now it says plus, it's inside the parentheses though, so it's going to be opposite of what we think, left. And the minus 4, it's going to affect up and down. In this case, it'll translate 4 units down. Okay. Now this is a very good graph. Now notice again, we've been dealing with what is called vertex form, and this is what we would call vertex form. So again, remember that standard form is of the form y equals ax squared plus bx plus c. And this one is y equals gx. Now, lots of times you see a instead of g. But in this table right here, we'll go with g. But for future reference, you might see an a there. But the rules are the same. So this is vertex form, and we've been looking at that and using it. G, and which I described as also being a sometimes, if it's positive, it opens upward. If it's negative, it opens downward. The width of it, again we said for G, is if it's between 0 and 1, it's going to make it wider. If it's greater than 1, it's going to be narrower. And you can ignore the sign, the absolute value symbols here, because the absolute value symbols are just saying look at the number, not the positive or negative value, because that's addressed up here. If it's positive, it goes up. If it's negative, it goes down. And you also have horizontal slides. We talked about if H is positive, it goes left. Opposite of what we think. If it's negative in there, it goes to the right. In vertical slide, it goes, if it's positive, it goes up. If it's negative, it goes down. So we've already discussed that. Alright, so here ends lesson 8.3 and 8.3, part A.